Your phone unlocks when it sees your face. Your email knows which messages are spam before you do. YouTube somehow knows you want to watch this video right now. But here is the strange part. No programmer wrote specific instructions for any of this. These systems taught themselves. They looked at millions of examples and figured out patterns that even their creators cannot fully explain. This is machine learning, and in the next 8 minutes, you are going to understand exactly how a pile of silicon and electricity learns to do things that seem almost magical. Let us start with a question. How would you write a program to recognize a cat in a photo? Think about it. You would need to describe exactly what makes a cat. Pointy ears. Some cats have floppy ears. Fur. Some cats are hairless. Whiskers. Dogs have whiskers too. This is the wall that traditional programming hits. Some problems have so many exceptions and variations that writing explicit rules becomes impossible. We needed a completely different approach. Here is the insight that changed everything. Instead of telling a computer exactly what to look for, what if we just showed it thousands of examples and let it figure out the patterns itself? Think about how you learned to recognize cats as a child. Nobody gave you a rule book. Your parents just pointed at cats and said cat over and over until your brain built its own internal model. Machine learning works the same way. Learning from examples instead of following instructions. But wait, computers do not have brains. They do not have intuition. So what does learning actually mean for a machine? Here is the key. A machine learning model is really just a mathematical function with thousands or millions of adjustable settings called parameters. At first, these parameters are random. The model's guesses are garbage. But we show it an example, check if it got the answer right, and then nudge those parameters slightly in a direction that would have made the guess better. Do this millions of times, and those parameters gradually tune themselves into something that actually works. This is where training data comes in. The examples we use to teach the model. Training data is the secret ingredient that makes or breaks machine learning. Show a model 10,000 photos of cats and dogs, labeled correctly, and it learns to tell them apart. But here is the catch. The model can only be as good as its training data. If all your cat photos are orange tabbies, the model might think black cats are dogs. Garbage in, garbage out. The quality and diversity of training data matters enormously. Now let us talk about the three main flavors of machine learning, starting with the most common, supervised learning. This is learning with a teacher. You give the model inputs paired with correct outputs, like photos labeled cat or dog, emails labeled spam or not spam. The model learns to map inputs to outputs by studying these examples. Your email spam filter works this way. It learned from millions of emails that humans had already marked as spam or legitimate. Every time you click spam on a dodgy email, you are actually helping train the model further. But sometimes we do not have labels. We just have raw data and we want the computer to find interesting patterns on its own. This is unsupervised learning. Imagine you run an online store and you want to understand your customers better. You dump all your customer data into an unsupervised model and it might discover, hey, these customers tend to buy electronics at night, while these customers buy groceries on weekends. You did not tell it what to look for. It found clusters and patterns you might never have noticed yourself. The third type is reinforcement learning. Learning from trial and error, with rewards and punishments. This is how we train AI to play games. The model tries random moves and we give it points when something good happens and negative points when something bad happens. Over millions of attempts, it learns strategies that maximize its score. This is how DeepMind's AlphaGo learned to beat the world champion at Go, a game so complex that no human could write rules for it. The AI played millions of games against itself until it discovered strategies that even grandmasters had never seen. Let us see this in action with something you use every day. Recommendations. When Netflix suggests a show, it is using a mix of supervised and unsupervised learning. It knows what millions of users watched and rated, that is supervised data. It finds hidden clusters of users with similar tastes, that is unsupervised pattern finding. Then it predicts that if you like these 5 shows, and users like you also love this 6th show, you will probably enjoy it too. The model does not understand stories or emotions. It just recognizes statistical patterns in behavior. But machine learning is not magic, and it goes wrong in fascinating ways. Remember, models learn patterns from training data, even patterns we did not intend to teach. One famous example: a model trained to detect tanks in photos learned to detect cloudy weather instead, because all the tank photos happened to be taken on overcast days. Another model learned to identify dogs by detecting grass in the background. These models were not wrong. They were perfectly following the patterns in their training data. The training data just contained accidental shortcuts that had nothing to do with what we actually wanted to measure. There is another trap called overfitting. Imagine a student who memorizes every question from past exam papers but does not actually understand the subject. They ace old exams but fail completely when they see new questions. Machine learning models can do the same thing. Memorize the training examples so perfectly that they cannot generalize to new data they have never seen. This is why we always test models on fresh data that was not used during training. A good model does not just remember, it truly learns the underlying patterns. So, where is all this heading? We are living through an explosion of machine learning capability. Large language models like ChatGPT learned from trillions of words of text and can now write, code, and reason in ways that seemed impossible 5 years ago. Image generators learned from billions of pictures and can now create photorealistic images from text descriptions. Self-driving cars are learning to navigate from millions of hours of driving footage. The models are getting bigger, the training data is getting larger, and the results are getting more impressive and more important to understand. Here is why understanding machine learning matters. Even if you never write a line of code, these systems are making decisions about your life right now. Whether you get approved for a loan, which job postings you see, what news stories appear in your feed. Machine learning models influence all of it. Understanding how they work, their limitations, their failure modes, gives you a more accurate mental model of the world around you. You do not have to build these systems, but being literate in how they function is becoming as important as understanding how the internet works. Let us lock in what you learned today. 1. Machine learning is teaching computers through examples instead of explicit rules, by adjusting millions of parameters until patterns emerge. 2. There are 3 main types: supervised learning with labeled data, unsupervised learning that finds hidden patterns, and reinforcement learning through trial and reward. 3. These models are only as good as their training data, and they can fail in surprising ways when that data contains biases or shortcuts. Now that you understand the fundamentals of how machines learn, you are ready for the next step. Understanding neural networks, the architecture that powers everything from ChatGPT to image generators. That video is coming next in our AI track, so subscribe and hit the bell so you do not miss it. And drop a comment below. What is one thing you wish AI could learn to do for you? I read every comment. See you in the next one.